welcome to QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about the Airbus Quantum Computing Challenge. And for this, I'm honored to have no one less than the leader of the winning team, Giovanni Pilon. Ciao, Giovanni, and welcome to the show. First of all, congrats for winning this exciting Airbus Quantum Computing Challenge. How are you today?
Hi, Rene. First of all, thank you. Glad to be here and to talk about quantum. And yeah, all good.
Awesome. Before we start, can you tell us a little bit about yourself and your background as it relates to quantum computing?
Yeah, so I'm an engineer and I've been working for machine learning reply for the past 3 years. And my background is a mix of mathematics and computer science, which is pretty much what you need to deal with quantum computing. And I've been doing research on this topic pretty much since when I joined the reply.
Nice. So tell us a little bit. I mean, I already gave it away that you guys won the Airbus Quantum Computing Challenge, and that is super exciting, of course. But first of all, what was the Airbus Quantum Computing Challenge all about?
Yeah, so the Airbus Quantum Computing Challenge was an international challenge held by Airbus through 2019 and 2020. And their goal for this challenge was to explore how quantum computing can be used to solve some real business problem that they have in the aircraft and the aerospace industry. And this is what's really interesting about this initiative, in my opinion, which is the fact that these are real business problems. It's real tasks that are difficult to solve for classical algorithms. And so they wanted to explore, at least from a theoretical point of view, how they can benefit from this new technology and how it can be applied to these business problems.
Well, that's also the goal of our show here, right? With QuBites, like
Yeah,
focusing on the impact we're already seeing today with applied quantum computing. Because, like, well, a lot of people think basically that this is still science fiction, many years out until we have true quantum computing hardware with quantum supremacy. But this is not the case. We can already apply quantum-inspired computing, quantum algorithms, even on classical hardware, and achieve great results, especially in the optimization space, right? But let's dive into your project and what your team worked about. So maybe you just want to tell us a little bit about your team. Also, what was your project about and how did you manage to win it, of course?
yeah. So the project, starting from the project, it was we focused on the problem, which was about aircraft loading optimization. And what you have to do in this problem is to load as much weight as possible on the plane while respecting a lot of flight constraints. So, for example, you shouldn't load too much weight. You have a maximum weight limit. Then the center of gravity should stay between an upper bound and a lower bound. Otherwise, the plane will not be balanced. And also, the distribution of the weight should stay below a distribution curve that they give you as an input. So you have a lot of constraints to respect. And these, of course, are all meaningful constraints from a flight perspective. Um, my team was made by me and two colleagues of mine from machine learning reply. Uh, but we have to say that the reply was doing a great job and is still doing a great job on quantum. In fact, we had a quantum computing hackathon back in 2019, and we had, I think, among all the companies, we had multiple submissions, like 3 or 4 for this challenge. And speaking from our team, what I can tell you is that we had a lot of focus on the mathematical correctness of the model. We were able to solve all the constraints. So all these different constraints, we were able to map in the same quantum computing model, and we were able to solve. So proving and to prove that it was correct, we were able to benchmark it both on real quantum annealers, because as you said, we are using quantum optimization, and also on classical solver. And another interesting thing about classical solver, quantum inspired solver, is that they're useful not only to have a solution today, but also to prove that, in this case, to prove that the mathematics and the equation were correct and that in fact we were getting feasible solution. And another thing I want to mention is that it's not only about having a solution today, but also about being ready for this technology if keep getting more scaling, more qubits in the future. So I felt that the interest of Airbus was somehow also theoretical, meaning what is the model, what is the math that allow us to solve this problem on these machines in the future.
Gotcha. Well, that's exciting. You're basically saying you developed a mathematical model or an algorithm and quantum algorithm that can then solve these, well, big challenge of how can I optimal load my plane that I maximize the output, right? That I have the maximum amount I can transport while also having not too much fuel and also, of course, fulfilling all the constraints, right? Needs to go from A to B and
Yeah,
maybe in between some few more stops. And so definitely a big challenge. And I mean, when you tell me you actually solved it with a model you guys developed that is not just a theory, but you also were able to run it
yeah, to
with a
benchmark it.
solver to benchmark it, right? That is exciting because it's not just theory then, it's actually real, practical, and you have proven that it works.
Yeah,
And well, awesome. Well, again, congrats. I mean, that's for good reason. You guys won that for sure. This is like I said, it's a big challenge, right? And so, what are you guys doing with this now? What are the next steps? What is Reply doing in these areas? And can you maybe share some examples of other current impact we're seeing?
yeah. So of course, we are always staying updated. In this field, you have to stay continuously updated on the latest trends and achievements. So that's for sure one activity that we are constantly doing, and also working, as I was saying, with the classical solver that run on CPU or GPU. We are able to do simulation or let's say provide a quantum inspired solution for this kind of model. And for example, one use case that I can share, something completely different from the Airbus one, is portfolio optimization. It's something we developed a couple of years ago, and also in this case, it is the tricky part is that this kind of optimization, like in the one of the aircraft, are combinatorial problem usually. So once again, for classical algorithms, it becomes really difficult to test all the possible combinations. And in this case, we are still expanding and extending the work that we have been doing in the past, and we have some prospect. So that's well, another use case that's interesting to mention for sure.
Yes, totally see that. How, for example, how can you also optimize your financial investments, right? Because these are like super complex problems. I mean, these are multi-dimensional optimization problems in the end,
Yeah,
right?
yeah.
And you need to find your way through all these dimensions to find your
Exactly,
optimal.
exactly. You can imagine exactly like that. If you think about a combinatorial problem, it's a lot of combination of choices, and the amount of combinations that you have to test just scale exponentially. So you need
Yeah.
an alternative approach, either classical or quantum.
Okay. Last question on the Airbus Quantum Computing Challenge. What was the prize? What did you guys win? And how many other teams were actually also taking part in the contest?
Yeah. So the prize was a collaboration with Airbus. So that's something that's ongoing, and that's it pretty much. So it's yeah.
How many other teams were there?
So there were at the beginning there were something like 800 people registered for the challenge
Wow.
at international level. However, the amount of valid submission, so the submission that was actually accepted and evaluated, was just 36. So apparently, already providing a submission was not an easy task.
Yeah, it was quite a big filter. But anyway, I mean,
But
just
the paper
imagine that,
is
right?
our paper is online. Sorry, by the way, if you're interested, it's on our site now. We publish it just recently.
Oh, that's good to know. We will definitely put a link into the show notes here that people can access that and check out and read all the details about that paper. But I just wanted to finally say it's pretty amazing actually if you think about 800 submissions initially and you guys won out of that. Although they reduced it to 46, but that is a huge achievement. So again, congrats,
Thank you,
congrats.
Rene.
Unfortunately, we're already at the end of the show. Thank you so much, Giovanni,
Thank
for
you.
joining us today and sharing all about this new exciting work you're doing and the Airbus Quantum Computing Challenge. Very much appreciated. Thank you, Giovanni.
Thank you, Rene.
Well, all right, folks. Thanks everyone for joining us today for another episode of QBites, your bite-sized pieces of quantum computing. You know it. Watch our blog, follow our social media channels to hear all about the next episodes once we publish them. And so long, take care, be safe, and see you soon. Bye bye.